Good afternoon, and thanks to everyone who has joined me today. Welcome to our first LinkedIn webinar at Perfect Service Solutions. If you're viewing this recording via YouTube after the event, thanks for checking in. My name is Simone Hart-Sibbald and I'm Managing Director of Perfect Service Solutions. I'm also Vice Chair of the National Association of Air Duct Specialists UK, otherwise known as NADUC. We've been in the business of grease extract cleaning for nearly 17 years, and for over a decade, we've been looking for that silver bullet to address the many challenges and risks associated with the cleaning of kitchen extract systems. I've always been open to innovations and new technologies, and I've kept myself abreast of what's hot and what's not in the industry. I spent lots of time with colleagues, stakeholders, clients, both large and small, evaluating and considering the pros and cons of methodologies that address grease build-up in kitchen extract. It's not unexpected to conclude that there isn't a one-size-fits-all, and we very much understand that each client has different pain points. I'm still learning and exploring, so I don't profess to be an expert on every system, but I think it's a great topic to explore and consider. If you have any questions during the webinar, please submit them via the chat and I will try to address these at the end of the event, or feel free to contact me via LinkedIn after the event. I do want to include a disclaimer. The information and summaries provided in this webinar today are intended to be insights only, and they're an intention to share known and emerging alternatives to traditional grease extract cleaning. There's no intention to endorse or criticise any system. So, as well as exploring the alternatives to traditional grease extract cleaning, our agenda today will cover the background to this service. I feel it's important to cover why there is a need for grease control in kitchen ductwork and some of the challenges faced by clients and duct cleaning companies with traditional methods of cleaning. Some of the information you'll know about, some you might not. So why do we need to clean kitchen extract systems? Most people know why. It's a fire hazard. And although to date, as far as I know, no one has died due to a commercial kitchen fire, that is by far the most compelling reason to address a known and very real fire risk. Insurance companies also require evidence that cleaning has taken place and that grease buildup is being removed by a third-party contractor, especially in the event of a fire and a potential claim. However, not everyone knows or is aware that cleaning of grease extract is also covered by legislation. Food safety regulations, used significantly by environmental health departments within local authorities, provide guidance stating that ventilation systems must enable cleaning and be readily accessible. Fire safety guidance associated with fire safety legislation also refers to the importance of grease and fat deposits being removed from extraction equipment. But as I've said, there are significant challenges associated with this service. What are these challenges and how do grease control technologies address these for the client and the grease extract cleaning companies? Well, firstly, we've inherited significant problems with access and ventilation systems, often due to the lack of thought or indeed care about future maintenance. Sometimes we just can't reach parts of the ductwork to remove the grease. Day and daily, we see examples such as large and lengthy internal and external risers, often found in old buildings. Ductwork that's installed above suspended ceilings, causing working at height issues and the requirement for expensive access equipment. We see duct obstructed by other services such as gas pipes, trunking, cables, running alongside, above or below the duct. And ductwork located behind solid ceilings with no point of access at all. Our surveyors often have to be very inventive and skilled in determining how we will access all of the grease extract in buildings safely. Duct cleaning can also become cost prohibitive. Budgets may not allow for the frequency of cleaning required to address the grease build-up. There is also a false perception of the true costs of duct cleaning, which results in only part system cleaning. Then there are rising labour, energy and transport costs post-21 that are inevitably affecting and increasing prices. Many are aware of poor standards that we see in the grease extract cleaning industry, and to date, although this is being addressed, varying levels of expertise and skill result in poor or partial cleaning. That is changing, but it's happening slowly. Then there's the question of how an end user can truly monitor the level of cleaning within their kitchen extract systems when duct is back of house. It's behind closed inspection hatches and often in inaccessible, dark and dingy places. No doubt my listeners may think of other challenges and risks to their businesses. As a duct cleaning company, we carry a lot of risk too, and I know we can find a better way that not only improves the service for our clients, but also for our employees and their welfare. So, in come the grease control technologies and innovations. What are their objectives? When innovators looked at the challenges of grease control, they considered various objectives and are generally trying to achieve the following. Firstly, ongoing cleanliness. The grease starts to build up immediately after a grease extract clean, and it continues to build until the next clean. Is that 3 months? 6 months? 1 year later? We see huge micro levels of grease in systems after relatively short periods of time. I could show you photos, but it's lunchtime. Secondly, they want to achieve cleanliness in the whole of the ventilation system, not just part of the system, due to prohibitive labour costs or access issues. All of the systems presented today claim over 95% grease capture or mitigation. They also endeavour to be at least cost neutral where possible. For example, the cost of the technology is offset by the reduction in the duct cleaning costs, the cost of the access equipment, or added sales from not closing. As well as that, there's always a requirement to reduce the health and safety risk for contractors. Risks to people such as working at height, contact with hazardous chemicals, confined spaces, etc. Minimising business disruption is another one. Having to accommodate duct cleans during a night shift, whether that be staff rotated on, key holders, or having to close if you're a 24-hour food service. And of course, the systems have to be robust and reliable. Consideration is also given to the complexity of a new system for staff. It has to be manageable. And last but not least, all of today's innovations are concerned with sustainability and environmentally friendly solutions. Another interesting point about the systems is whether they are active or passive. What do I mean by that? This slide is pretty self-explanatory, but active systems require an external power source. They require servicing and maintenance due to mechanical parts, but due to the mechanics, they're often fit and forget whilst they're running. On the other hand, passive systems require no power supply. They don't have mechanical parts, so there's no servicing or maintenance requirements, but it will require staff or a service contractor to do something, perform a periodic task or certain tasks to keep the system running. So, without further ado, let's consider the technologies, which is why you came here today. The first one on our agenda is biodosing. What is that and how does it work? Well, biotechnology is the integration of the natural world with the engineering world using organisms such as good bacteria and enzymes. So bacterial solutions are used in high or low pressure systems with spray injection nozzles that distribute the solution throughout the ventilation system by spray, mist or fog. The solution then adheres to the ductwork, and the good bacteria produces enzymes that break up and digest the food source, which in this case is fats, oils and grease. And the food source itself causes the good bacteria to replicate and convert to biofilm until reactivated again. So things to know about this technology. As I've said, it uses biotechnology, which is sustainable. It's cleaner and greener, therefore. The organic matter is degraded into oxygen and water. It eliminates the use of hazardous chemicals used in the duct cleaning process. The bacteria removes odour. Remote system monitoring and reporting is available. It does require regular visits because the fluid or solution requires replenishment, and there needs to be inspection and TR19 reporting and sometimes hot spot cleaning. The capital investment for this system is regarded as medium, but there are options to lease the equipment. Wool filters. Well, there's a growing interest in wool filters due to their simplicity and their green credentials. They also protect and offer extended life and efficiency to expensive odour control systems such as activated carbon. So how does it work? Well, these are alternative stainless steel baffle filters that are used in the Canopy in conjunction with 100% wool pads. Data sheets on them claim up to 98% grease capture. The process? Well, greasy vapours are drawn through the wool filters, whereby the grease particles naturally adhere to the wool fibres upon contact. The captured contaminants are stored along the wool fibres. This prevents blocking and is why airflow reduction is negligible. As the wool fibres approach their capacity, small droplets of grease begin to form on the outer face fibres of the wool filter. These droplets are the visual indication that the filter needs changing. What is there to know about wool? Well, wool's high nitrogen and water content makes it naturally flame resistant. It does involve easy installation, and these baffle filters can be retrofitted to existing canopies. Filters, canopies, fire suppression systems and ductwork all stay cleaner for longer and significant extended periods between cleaning. And of course, wool is environmentally friendly and very sustainable. It's biodegradable, so it's carbon neutral, and there's zero waste to landfill. It protects HVAC ductwork and fans from grease and corrosion. And as the wool captures the grease, the filters change colour. The capital investment for this technology is very low. Ductless extraction and recirculation units have come on the market. They recirculate and clean the dirty air from grease extraction in the kitchen. The systems remove moisture, steam, smoke, grease and odour. What's great about these systems is that they're suited to spaces and layouts which normally wouldn't accommodate a kitchen in a commercial space. So places like airports, railways, listed buildings, basement kitchens, kiosks, island sites, and more. Because they require reduced or no planning permission, it's easy to have a change of use. They don't require external ductwork or a route to atmosphere. They still require some filter and canopy cleaning and some duct cleaning within the system. They can be used in conjunction with another pre-filter system such as wool. Many of the units do not control air temperature, so they're not air conditioning. Only to be used with electrical catering equipment, as most units don't remove carbon dioxide or products of combustion from the recycled air. And they're a great alternative to high-level discharge. They do require periodic maintenance and filter changing, and the capital investment required is high, but there's an option to lease and to relocate the equipment. UVC and ozone. Well, a few companies have combined ozone technology and UVC to try and address odour and grease. How does it work? Well, it works in the synergy that occurs when ozone and ultraviolet light are combined. UVC stands for ultraviolet light in the C-band, a very strong type of ultraviolet light. Using light energy on grease particles disrupts them, and they are oxidised to the ductwork with ozone, which causes contaminants in the air to be destroyed. This results in the reduction of odour emissions to the surroundings, as well as reduced grease deposits in the ductwork. UV lamps in direct contact with extract air provide a more intense effect than ozone injection. Things to know about the system: well, it treats grease, bacteria and odour. ESP combined with UVC and ozone units, the next technology we're going to consider, can be a highly effective pollution control solution. The use of ozone and UV does carry health and safety risks, though. It should be noted ozone systems carry inherent risks from toxic nature from the toxic nature of the high ozone concentrations within the ductwork, and there is potential harmful exposure to high intensity UV lamps. The system should never be on when the fan is off, and therefore the systems require protection interlocks, air pressure switches and signage. The capital investment required is considered medium to high. Coil filters. What are they and how do they work? Well, coil filters are canopy mounted stainless steel baffle filters to replace the standard baffle filters. As with traditional baffle filters, they work on extraction air before it gets into the canopy. Their data sheets indicate that they capture 95% of grease particles, which is a huge improvement on the typical 20 to 40% achieved by ordinary baffles. There are 4 stages to the operation for coil filters. Firstly, the oil vapours condense on the large surface area of the filter coils as heat is transferred from the air. The air is then spun into a vortex and the droplets of oil and grease continue in a straight line. These particles then collide with the filter coils and the oil-coated filter surface traps more oil and grease due to its enhanced viscosity. The oil and grease droplets simply settle due to gravity and then are collected for recycling. So things to know about this system. They're easy to clean, but regular cleaning of the filters is necessary. You do have to give consideration to airflow rates and the system pressure. Retrofitting to existing canopies is possible. And a nice feature about this is that the captured oil can be recycled. There's no chemicals involved in this process, and the capital investment required is low to medium, depends on how many canopies and how many filters are in the kitchen. ESP, which stands for electrostatic precipitators. These systems are popular with contractors and local authorities because of the reduction in nuisance that they present. They can also offer extended life and efficiency to expensive odour control systems such as activated carbon and UV ozone. They're designed to be fitted in line with kitchen ductwork before the fan. They draw the extracted air and then treat it in 3 stages with integral sumps to collect the oil, grease and smoke particles. The first stage is a metal washable air filter that removes large dust and grease particles in the airstream. The second stage, smaller grease and smoke particles will then pass into a strong electrical field where they become charged. And the third stage, the charged particles then pass through collector plates that are designed to attract and collect the smaller particles, resulting in clean air. Things to know about this system: it removes grease and smoke. They're considered to be energy efficient, and a single pass ESP can achieve a grease and smoke removal efficiency of 95 to 98%, depending on the manufacturer. The system does require regular maintenance to keep it effective and efficient, and the capital investment is high. And really, that concludes our foray into grease control technologies today. As I mentioned at the beginning of this presentation, different clients and different sites have different pain points. When considering a potential change in methodology from duct cleaning to grease control technology, end users will want to consider any or all of the following. Some of these systems can be used in conjunction with one another to form a hybrid solution that addresses more pain points. You'll want to obtain a cost-benefit analysis to compare costs and risks of current grease control measures. You'll want to look at the CapEx cost and how that will be funded. And overall, what's the lifetime cost of the system? And give consideration to the servicing and maintenance needs of the system. So that's it for today, folks. I see I'll go into the chat and see if I have any questions for today, but feel free to connect with me on LinkedIn and send me any of your questions. And also please follow our Perfect Service Solutions Company page too.